Yeah, China will ban to. China will ban to is everywhere, right? Let's call this hand.
Distinction.
Distinction. Yeah, so China ban to is everywhere, man.
China about to everywhere. China about to everywhere.
Everywhere.
China about to
Exactly.
everywhere.
Thanks. How you doing, man? So there's a question right here. So a lot of people that have a problem with this question, and they say, "Oh man, how I'm gonna know is separable variable, or how I'm gonna know this type of differential equation is Bernoulli or exactly solution?" So because most of the video I see people is solving, but they're not telling people, student, on how to identify, because in exam they're not gonna say this is Bernoulli's or this is differential equation by exactly, or this is differential equation by separate variable. No, they're not going to tell you none of that. They just give a question, they say solve. So now I'm going to show you how to identify and how to solve. So they give a question right here. So just by looking, you need to open your eyes wide open. Okay, look, for example, this we know is going to be Bernoulli's. How I'm going to know? In any Bernoulli's differential equation, you got okay, this is second order, first order. This is a first order. First order is like dy dx, but when d square dy dx square the second order. So this is first order, and here this is a function of x and the y. So whenever you have a function of x with y, then you know, oh, that's Bernoulli's. In this area here, it must be x with y. And this number here should not be 1 or should not be 0. This number here, you see, this power y, it should not be either. It should neither be 0 or neither be 1. And then this is going to qualify to Bernoulli theorem. You know what I'm saying? So I've written the formula for you to identify Bernoulli theorem means this is first derivative. When you say y prime means this, let me say, this one here, let me say dy dx. So you see p of x, p of x means it's like 1 of x, and then there's a y. See, there's a y. Function of x, see, is x squared, but it could be any, so it gotta be this format, and then you have a y power something. See here, you got y power something, and this in here, I'm saying it again, it should not be 0 nor 1. So it could be 2, 3, 4, 5, but if it's 0, 1, then it's not Bernoulli differential equation. You know what I'm saying? So now, for example, so this one qualified. You know why it's qualified? Because I'm going to say this is the same as say, oh, y prime, and then we plus, see, you can compare the equation, equal to p of x. Oh, so this one of x is p of x. You know? So this is one of x. Excuse me. This is p of x. So this is the same as say p of x. See? Check the formula, Oh, there's a y. Oh, so you see there's a y. So it's like say y. Oh, and they come here. There's a q of x. Oh, there's q of x. And this is y power. And you know what I'm saying? So, oh, this is Bernoulli's or Bernoulli's differential equation. So, you know what is a p of x? 1 of x, and then there's everything gap. You know what I'm saying? So, before I go further, sometimes they might give stuff like this. You see, so it's not in the right form. So what I'm going to do, because if you come in Bernoulli's, you don't need anything prior to y prime or prior. This means dy dx. So you don't need anything here behind. So what I'm going to do here, I'll just multiply by y squared to rearrange. So it could be in the Bernoulli's. So multiply by y squared. If you multiply this by y squared, okay, and here multiply by y squared, and this multiplied by y squared. So what happened? These and they cancel, and they 1y and y cancel, and this is going to be y power 4. Oh, so we're going to have a y prime, but a y prime means dy dx first order, okay, and then with plus, okay, so it's going to be 1y and 1y cancel because we multiply by y squared, so it's going to be y times 1 of x, and they equal 2x cube times y power 3. So you see now it's already went to Bernoulli theorem. So sometimes you give an equation which is not in Bernoulli theorem, then you have to rearrange. So we know this is going to be our p of x, and this is going to be q of x, and then our n equal to 3, and this 3 is not equal to 0 or it's not equal to 1. So this qualifies as Bernoulli theorem. Now let's go back to the business, because this is not part of the business, okay? Now, so they give us this. There's something called integration factor. So you need to get the integration factor. So for this case, integration factor, if you have a y power n, integration factor equal to integral 1 minus n px, we know px, you know what I'm saying? Means something with the x times d of x. So now, I'm going to come here first. First and foremost, I have to identify what is my p of x. P of x equal to 1 of x. So my p of x equal to 1 over x. Okay? And then my q of x equal to x squared. So my qx equal to x squared, and then my n equal to 3. Also, I got all my information. So what I'm going to do, I'll start to solve. Let me find the integration factor. So getting the integration factor first. So how we're going to get integration factor is easy. You know, our integration factor according to the formula, this one right here. Okay, integration factor. Integration factor equal integration factor equal to e, and they say integral 1 minus n. But what is the n for this case? N equal to 3, this number. So 1 minus 3. And then we got here p of x. What is a p of x? Our p of x is 1 over x. Okay, our p of x is 1 over x here. P of x equal to 1 over x. So 1 over x. So 1 over x. And then times d of x. Oh. So this is going to help us to get integration factor. Okay. Let's get an integration factor. And there we go. Okay. Okay. So integration factor equal to, we have e. Now this is going to be negative 2. Negative 2 comes out. And then integral for 1 over x. And then d of x. So this time we say e negative 2. But when you integrate 1 of x is ln of x. Ln of x. And then, yeah, that's ln of x. That's what we got. So what I'm going to do, I'll take negative 2 back. So integration factor, okay, is going to be equal to e ln this negative 2 is going to come back. So it's ln of x negative 2, which is same as say e, okay, ln 1 over x squared. But this mathematical equal to 1 over x squared. Like all this stuff equal to 1 over x squared. If you have an e power whatever you have, but it must be ln. That's why I took this one back. So this equal to 1 over x squared. Only if you have a ln. Stuff like this. So e power ln of whatever you have equal to that. So integration factor is 1 over x squared. So what we're going to do now, if you got your integration factor, so you go to your formula. The formula, you say y. So there's a formula here, you memorize general formula. So what you go to 1 minus n for Bernoulli's, you know what I'm saying? And then equal to 1, and then you over your integration factor. And after that you can say bracket, and the integrate, and after integrate say 1 minus n. 1 minus n, and then q of x. 1 over n q of x, and then you multiply again by integration factor. This is a formula, right? You just memorize. And then you say d of x, and then you plus your constant. So you substitute. So we say if you plug it in, so this is going to be 1 minus n. Our n equal to 3. So y 1 minus n equal to 3. So 1 minus n equal to negative 2 equal to 1. What is the integration factor? Integration factor is 1 over x squared right here. So it's going to be 1 over x squared. This is the integration factor. And then integral 1 minus n. 1 minus 3 equal to negative 2. Okay, our q of x. What is the q of x? Our q of x equal to x squared. So you can plug that in. Our q of x equal to x squared. Oh, so this is going to be x squared. Integration factor is 1 over x squared, because we had an integration factor right there. So what we're going to do, this is dx, and then we plus our c, and then we cross a bracket. You know what I'm saying? So what I'm going to do, I can reciprocate this and say this is equal to 1 over y squared equal to, this is going to be x squared, because it's going to go to the top. And then negative 2 is going to come out. But look, x squared and x squared, they're going to cancel. So what we're going to have here, we're going to have negative 2 integral of dx. So when you integrate dx, you get x. When you x, and then we got negative 2, remember, plus our c. And here's x squared equal to 1 over y squared. So what we want now, we can isolate y, because at the end of the day, when you integrate, you want to get we want to write y separate. So I'm gonna multiply this y here, and that will divide by all of this. So it's gonna be 1 over x squared negative 2x plus c equal to y squared. So what I'm going to do, square root throughout. So now square root here and square root on the left hand side too. So finally, y equal to square root of 1x squared negative 2x plus c. Thanks a lot of it. And it's easy like that, man. Thanks a lot of. You know what I'm saying? Look, man, I believe in learning from how to do things. If first time, make sure you subscribe, and you know, you can just go and do donation to our Patreon page. I have a Patreon, I have a GoFundMe. You know what I'm saying? I have all the means of donation, because to make this project going, you know, any type of donation, the little that you think is too small for you, it could make a lot of change. And thanks a lot for all your time, you know. Subscribe, don't forget, share this video, circulate to a lot of people, you know, because the meaning of this project, this program, is to help as many as we can. Okay, it's not only for one person or two, because you might think it's not helpful for you, but for somebody next out there, it could be very, very helpful. So thanks a lot, man. And you know, any donation that you did to me, it means so much. I appreciate it, man. It means a lot. Go to our Patreon page, go to our GoFundMe, because we need to have a lot of things. We need to put them together, like camera, you know, and a lot of equipment, so that we can improve on, you know, a lot of angle, a lot of aspects of these projects, you know. Thanks a lot, man. I appreciate and I love you. Peace and out. Bye. You know, this is one of my students of knowledge. You know, she wanted to introduce herself. What's your name? Could you please introduce yourself?
My name is Bernoulli.
Yeah.
I go to Sinx primary school.
Yeah, China Wabantu. China Wabantu is everywhere, right? So this is my other student. His name, what's your name?
Matthew.
Matthew, yeah, he's grade 11, man. So his aim is to score distinction, right? So you promise, I want you to score distinction this time. And what's your name?
Joshua.
Joshua, how much you promise me to score this time?
Distinction.
Distinction. Yeah, so China Wabantu is everywhere, man.
China Wabantu. Everywhere. China Wabantu everywhere.
Everywhere.
China Wabantu.
Exactly. Thanks a lot, man. Appreciate it. Thanks so much. If you had to give advice, which advice would you give to the people or to the students?
Trust Amish.
Why would they trust me?
No, because it's really good. They actually has helped a lot. I redid first year for maths. It was my own fault, but also I didn't know a lot of the work. And Amish said lots of hard questions, and it's demotivating sometimes to do the harder stuff. You like just want to get done, but it's the hard stuff that makes you realize the easy stuff is easy.
Ayapuma matoda